Hi guys, welcome to my channel Design Fire Protection with Kamal Ram. So I hope you have seen all my videos on design rules from 1 to 12, like how to classify building occupancy, and then sprinkler components, their spacing and the maximum coverage by each sprinkler, and their distance from the wall, and the protection area by one riser, and then sprinkler types and their application, and then all this floor control station, then ICV alarm check wall, and now you know how to design a system. Suppose you are given one floor plan, and now I hope you can design a system by learning all the previous design rules videos. So guys, now you know how to design an automatic sprinkler system using all the design rules explained in previous videos. So the next step is to perform hydraulic calculation. So first of all, why do we need a hydraulic calculation? See, this is done basically first to get the total water demand. So suppose you have a building, so how much we need total water demand? That means what is the water tank capacity? That is your first step we get from hydraulic calculation. And then the second thing is the total system pressure. That means how much you need a pressure for the fire pump to operate. What is total pressure required for this building? So it can be fire pump, or it could be like your other source, like your fire hydrant somewhere nearby, from where you can tap from fire hydrants. Now the next thing you can do is to calculate your pipe sizes or verify the existing pipe size which you designed using pipe meter from the NFPA 13, the tables. Tables we discussed in previous videos, like the 1 inch can carry up to 2 sprinklers and 1/4 can 3 sprinklers. So after you have designed pipe based on these rules, then you have to calculation, you have to verify this pipe size whether they're correct or not correct. So after getting all this data like water demand, system pressure and the pipes verification, the next step is to get the fire pump size, like the fire pump pressure and flow. Which is fire pump pressure and flow. And the next, from this, once you get the fire pump flow, then from that you can get water tank capacity. How much is the water tank capacity? So let's summarize. So we do calculation basically to get total water demand, total system pressure, pipe size verification, and fire pump capacities like GPM and pressure. So our calculation starts with the fundamental equation given in NFPA 13. So it says that the Q, the flow rate, is directly proportional to the square root of pressure. So this means that when the pressure is increasing, the flow rate also will increase, but it will not double the pressure actually. So instead the flow rate will increase by the square root of the pressure increase. So basically I can say that this Q is directly proportional to the square root of P. Okay, and then to remove this sign, the proportional sign, I have to write Q is equal to some constant, any constant, okay, that we call the multiplier. So it is called K factor. So K factor is a multiplier that determines how much the water flow through the sprinkler heads at a given pressure. So the different sprinkler heads have different K factor based on the design and the application, and it is given by the sprinkler manufacturing company. Okay, so now let's see. So the K factor usually range from 4.2 to 5.6 for these smaller homes like the residential buildings, and for commercial application it can be from 5.6 to 8, and for higher challenge sprinklers like the more extra hazard, it can be 11.2 or 14 or even more. So this K factor, so we'll discuss in detail later. So it's okay, and then what is pressure at the sprinkler head? So basically the amount of water that flows through the sprinkler head is called flow rate, and it's measured in GPM, gallons per minute. See the pressure is simple actually. So you know that, so it is basically the pressure at which the water flows from a sprinkler. So it is measured in pounds per square inch, PSI. See, so a sprinkler with a lower pressure will yield a lower stream of water, whereas a sprinkler with a higher pressure will produce a much faster stream. So I hope until now it's clear. If you have any doubt, you can ask me in comment section. Now let us solve some questions on this equation k is equal to q root p. See, the first question is given a sprinkler with k factor 5.6. So you can write here. So k is equal to 5.6, and then a water pressure of 7 psi. So I can say here P is equal to 7 psi. See, calculate the flow rate of the sprinkler. So you need to calculate Q actually here. This is pretty simple actually. This is not a problem. So I can write Q. Q is equal to K root of under P. Okay, and put all the values. So K is 5.6 and P is 7. So you will get Q is equal to 14.84 GPM. Okay, so the next question. The second question is also easy. The flow rate to sprinkler is 50 GPM and the K factor is 8. What is the pressure at the sprinkler system? So now here no, see here you know Q. Q is how much? 50 GPM. And you know K. So K is given is 8. So you have to calculate P here. How much P actually? So no problem. You just reverse the equation. That means you can write here. So P is equal to Q by K the whole square. Correct? And put all the values like Q50, K8. So we'll get P is equal to 39.06 psi. Correct? Understood? Right. So next thing, the question number 3 actually. The sprinkler system like designer want to achieve a flow rate of 40 GPM through sprinkler the K factor 4.2. So what pressure is required a sprinkler head to achieve this rate? So this is also easy, right? The same like above you can do this one. Same, just for the same step actually above. So P is equal to this. Put the Q and K. So you'll get the answer 90.63 psi. See this writing, excuse me, because this I bought just new one, this writing pad. See, coming to question number 4. So if the pressure sprinkler head is doubled, so by what factor does the flow rate to the sprinkler increases, assuming the K factor remains constant? See, you know that for question number 4. So Q is equal to K root P. Now they're saying that the pressure double. That means the pressure becomes now 2 times, double actually. You can say that the new flow rate is equal to K times 2P. That is equal to 2 root P. That means 2 root Q. That means the flow rate will increase by square root of 2. Okay. Now the next. So two sprinklers having K factor 8 and 5.6 respectively. So if both are exposed to same water pressure, how do their flow rate will be? Just compare the flow rate. See, basically you can compare like this. So same here actually, you can do same thing. Question number 6, question number 5th actually, sorry, 5th. So you can write here Q1 is equal to K1 root of P. Okay, and then Q2 will be equal to K2 root of P. They're saying compare the flow rate. Right here, U2 by U1, that is equal to K root 2P, and then divided by K1 root P1. See, this gets cancelled actually here. So K2 basically 8 and K1 is 5.6. So we will get 1.43. So this means that the K factor sprinkler will have 43% higher flow rate than 5.6 K factor sprinkler at same pressure. Understand? So coming to question number 6. So calculate K factor of fire hose reel 1 inch, landing wall 1.5 inch, going to NFPA 14. See, going to NFPA 14 is standard for the installation of standpipes and hose system. The minimum flow requirements for a 1 inch fire hose reel is 100 GPM. That means here your Q is equal to 100 GPM at a pressure of 65 psi. That means your pressure is equal to 65 psi. So using the same formula, Q is equal to K root P. So K is equal to Q by root of P. So you put all the values of Q 100 and P 65, you will get 12.5 psi. So K factor of 1 inch fire hose reel is 12.5. See, this is required now when you're doing some calculation like in software, like a light or some software. So there you need to put that hose reel K factor. So this you have to calculate. They're not giving any in data sheet. Now the next is your landing wall. Using same process, K is equal to Q root of P actually here. See here no, according to NFPA, the same standard, NFPA 14. So the minimum flow at landing wall 1.5 inch or 2.5 inch, it is 250 GPM actually here. 250 GPM. Okay, at a pressure of minimum pressure equal to 65. See, the 65 is the minimum pressure for 1.5 inch landing wall. If your landing wall is 2.5, then your pressure will be, minimum pressure will be 100 psi for 2.5 inch landing wall. Okay, now using the same all the values in the data, so you can calculate here. So K is given by, that is 250 GPM divided by the square root of 65, you will get 31. Okay, so landing wall K factor will be 31 when it is 1.5 inch, and suppose when it is 100 psi, then it will come 25. So this is all required now when you are doing calculation with the softwares like Elite software. No, you need to input this K factor in your software. Okay, and the next the flow. See the high, I don't know yet. For that, no, generally we do some test actually. Suppose we have existing hydrant around your building. So what happens now? We have some flow test procedure on to NFPA 25. What happens now? From that we put some gauge in that hydrant, so we get one static pressure, that is the pressure when the water is not flowing, that is called static pressure, and then residual pressure, which is the pressure when the water is flowing. This is called residual pressure when water is flowing, and this is the flow we'll get from the meter. Okay, so here now you can use same factor. So K is equal to Q root of P. So you put all the values now. Here P is equal to 70 and Q is equal to 1245. You will get K is equal to 150 K factor for this hydrant system. So again, please excuse me for this bad handwriting. Maybe I'll improve it in later videos. So guys, if any questions, you can ask in comment section, or you can send me email also. Here are some more questions on this real world application. So these questions I'm not going to answer in these videos. So I want to check how much you understood from my teaching. So this question you have to answer yourself. Either you can send me email or you can put in comment box. So I will let you know whether your answer is correct or no. So guys, please you can reply in comment box whether this you are understanding from my videos or you need more explanation or more understanding or how I should improve myself. So please give feedback in comment section. Not the video too long, so I have broken down the topics of these hydraulic calculations into several short videos to make it easier to follow and understand. So I'll stop this video now only. So please join my channel to get updated for the coming videos. To make videos not too long, I have broken down the topics of hydraulic calculations into several small videos to make it easier to follow and understand. So guys, join my channel for clear, simple and step-by-step explanation for each aspects of hydraulic calculation. And also, if you're interested in learning more about fire protection and plumbing system design, so join my YouTube channel, Design Fire Protection with Kamal Ram.